Good evening, everybody. Welcome to League of Extraordinary Inventors. I'm your host, Mike from Faraday Research. It is Free Energy Fridays. It's Friday night, February 7th, 2025. Welcome to the show. Last weekend it was Groundhog's Day. We had Wyerton Willie come out of his hole and did not see his shadow. So that means the early spring, hopefully for us here in Ontario. Philip, I guess you're still in Ontario. You're not in Quebec yet, so I guess you guys are going to have the early spring like us. But it's been a busy week. Gerald did a video, and Nathan's been busy on his live stream. Don't forget to check out Nathan's channel. Maybe Nathan, you could put that in the live chat or in the private, and then I could post it. And also Ben as well. Check out Ben's station, The Benefactor, and you can join him as well and be a member. And Nathan, you can also join his channel and be a member. Nathan, are you going to get a Patreon page going?
I have one.
Oh, you have one. Okay, maybe give me that link as well, and I'll post that in the live chat so you can help support Nathan in his work. Oh, there you go. Yep. I'll even flash it on the screen there for everybody.
That's just a YouTube channel there.
That's the YouTube channel there.
Yeah.
And there's Ben's station as well. Live chat is open. Any questions, comments for the panel? Please. Let's see. Trying to find something here. Save link. Copy. Okay. Sorry, I'm talking to myself while I'm doing that. Why did I do that? Put it in the wrong spot. So, Philip, I know you're headed off soon for the Super Bowl this weekend. Is there anything you want to jump into? Because I know you're going to leave early tonight.
So I just wanted to be part of your club, man. So I'm finally gonna be your friends because I am gonna experiment on this using similar material that you guys keep using. So it's pretty cool. We're more merging our efforts finally. I'm just gonna share my screen. One sec. All right. So yeah. So remember last week and the week before when I was talking about the annihilation process where an electron and a positron they collide and they create a photon, and the electric energy, the mass of the electron and the positron will determine the energy of the photon, and the electric field of the electron and the electric field of the positron will determine the kinetic energy of the photon, so its speed. That's why the speed of light is constant is because the charge of the electron and the positron are constant and they cannot change. So that's the reason. Last week the conversation was heavily dense, but to be clear, this is exactly, in simple terms, this is exactly what I want to say in the last few weeks. But it came to me, well, if I want to go, it's easy to go slower than the speed of light. If you use quarks annihilate as well. Quarks, they have fractional charges, so they have 1/3 of a charge and of a positive or negative charge, so they can annihilate as well. and they create mesons. Meson travels slower than a photon, but they claim that the mesons have mass because they have because they travel slower than the sea. But that's not the reason. It's because the real reason is because the charge of the quarks are fractional, so it's a fraction of a real charge. So that's why the mesons travel slower than c. But what if we want to travel faster than c? Is it possible? Because we need a charge greater than one e. We need a charge greater, like we need to double the charge. How do we do that? We cannot have super electrons that have two e's as a charge. They don't exist. I did the research and they just don't exist. So how can we do that? So it came to me a little solution. Actually, if according to my mathematics, this is a graph where the z-axis is the force. At the atomic scale, the z-axis is the force. The x-axis is the radius, and the y-axis is the linear charge density. So, if we increase the linear charge density, that is the linear charge density is the ambient charge, like the ambient charge density. Like in the atmosphere, there's a little 0.002 coulombs per meter charge density caused by the magnetic field of the Earth and its rotation and so on. It creates a little ambient charge density, but we can increase the linear charge density. If we increase the linear charge density, then there will be a strong nuclear force between the electrons, and the nuclear force. If you look at this graph and you go all the way up the z-axis, then you can see the y-axis. Sorry, you can see the force is spiking. It's getting greater and greater on the z-axis. So the z-axis represents the force. So you can see that the force is stronger when we increase the linear charge density. So that means that the electrons can have a strong nuclear force that will attract another electron. So all we have to do to attract electrons is to have an electron, some sort of do-it-yourself electron collider. We can use a cathode ray. They have an electron gun in it. Two of them facing each other. Then you will have electrons colliding. You'll have two electron guns, and you have in the middle of it you have electrons colliding, and at the exact spot where the electrons collide in the middle of the two electron guns facing each other, you install a solenoid that will create an electric field dense enough to increase the linear charge density. And once the linear charge density will be great enough, then the electrons will be able to fusion or merge together. So so in these conditions, the electrons will be able to merge together, and that's obviously it's a theory. It's pure theory. It's a pure theoretical experiment, but I could definitely improve it. I could instead of using cathode rays, could use these types of electron guns here. But it needs to be under vacuum, obviously. So yeah, so that's the part that is kind of similar to what Nathan and benefactors are doing.
Now, question for you. Oh, somebody's got their speaker on. Okay, that's better. Um, could you use a magnetron, say from a microwave oven? Would that be the same thing? What you're looking for, or no?
I think maybe, but I think my magnetrons is to create microwave, obviously, but
Yeah,
um, I need to create a gun of electrons. I don't know if it's possible with a magnetron. I did not investigate, so
yeah,
I need the cheapest way and the more reliable way to do it. Maybe a magnetron is the way, but I need two of them because I need two guns. I need two
right.
electron guns. So it needs to be under vacuum. So, but I don't know. I'll check it out. I'm not
Mm.
sure.
Yeah, you might be careful with that because it's microwave.
Yeah,
Yeah.
yeah. I'll hire MacGyver to help me out.
Yeah,
But yeah. So that's the idea of this experiment. And if the electrons collide together, then you have a super electrons with a supercharge, um, and obviously I'm not sure. I'm not sure. I wish I could do the same with the positron, but it's not as easy as it sounds. Ideally, I would have super electrons and super positrons, and then you collide these two together, and it will create a photon that goes faster than c,
Hmm.
faster than the speed of light. So because the charge is going to be greater of the input elements. So that's the idea. Maybe whoever is listening right now, maybe the military is listening or whatever. I don't know. Maybe they'll do it. Maybe I don't know. But if if not, then I'll end up doing it by the end of the year for sure. And there's a Patreon link that Mike posted, so you're welcome to help me out to perform this experiment, and I'll be happy to do it.
Hmm.
And other stuff I wanted to share that is more in computer science. We were talking about that half an hour ago internally, but the DeepSeek can be installed locally on Ubuntu 24.04 using Olama LLM. So it's very easy to install. You can Google it, and you'll have a. It's not too complicated. It's pretty straightforward, and you have the DeepSeek installed locally on your computer, on your Linux computer. So it's pretty easy to install. I'll do it next week. But this and the other thing I want to share is Meeting Hub.
Hey Phil, can you send me the link to that tutorial on how to install DeepSeek onto Ubuntu?
Sure.
Like put that in the private chat for me, because I'm gonna do that on my Steam Deck probably.
Okay.
Hmm.
Right here. And there's Meeting Hub for people who wants an unlimited number of users that you can stream on. You can use Jitsi, Zoom Meeting, Google Meeting, Jitsi Meet, WebEx, and you can stream on YouTube, and you can create live streams all over social medias for $129 for a lifetime usage. So it's not a bad deal. So because people were because people keep talking about alternatives to StreamYard, and I think that's a good one. So I did. It took me 5 minutes to search. I didn't spend a lot of time searching that, and you install it on WordPress if you have a web server. So you're gonna host it locally on your web server, which is good, and you obviously you're not limited to any number of users, stuff like that. So yeah, these are the things I want to share, and yeah, so help me out using the Patreon, and you'll get the results by this summer. About I'm also applying for grants.
Yep, that's
For
what we're doing too. So we're waiting on that, and now with all the Trump tariffs, we don't know how long it's going to take. But yeah, it could be 3 months, it could be 6 months. We don't know. So
yeah, but the tariff they're postponed. I think Trudeau just Trudeau kind of decided, oh, okay, it's time to work and put some and secure the borders and stuff like that. It's time to secure the borders after 8 years of Trudeau. So he finally decided to start working. So
yeah,
I think
a
Trump
little
just
too low.
sorry.
Yeah, a little too late for that now. He's
Yeah,
on the way out.
yeah, a little too late. Too little, too late. And but yeah, he's putting pressure on Canada to secure the border. That was his main intent.
Hmm.
But so yeah, so that's the cool stuff I want to share. And now I guess I can be. I'm passing the Nathan's test now to be part of his club.
Yeah.
Got to find out for that.
The initiation
Yeah.
process.
The initiation.
Well, I'll stand around the high voltage and chant. I zaps each one of us around the table.
Yeah, exactly. So,
It's like a sorority.
so yeah. So if you have suggestions, proposals, post it and post your suggestions in the comments. I'll read the recording. I'll I'll listen to the recording tomorrow in the plane or something like that when I go to San Diego. So so yeah, that was my talk, my speech I want to share with you guys tonight.
Bill, I had a small question. The photon that gets ejected from an electron that's transitioning from a lower orbit to a higher orbit is a different measurement than a photon being ejected from going to a lower orbital. Is that what I'm understanding? Like it's two different forms of photons?
So you're talking about the orbit of the atom in the atom?
Well, I'm talking about the energy photon emit. Is it a greater energy level when the photon is emitted because the electron went from a low orb, like a smaller, the inner orbital to the outer, on the electron valence thing?
Yeah.
Or does when the electron loses energy and it comes back to the lower and a photon gets ejected, which one has greater energy? The one that gets ejected when the electron goes to higher, or the one that when the electron goes to lower? Because both ways there's photons being ejected, but one.
Yeah, that's a good question. When an electron when an electron goes into a lower orbit, um, it, it, you need to give energy to the electron, so it's gonna absorb energy, and then it's gonna go to a lower orbit, and when it goes to a higher orbit, it loses energy. it's gonna lose photons. So, but I need to review that. I think that's what it is. I don't know by heart. But I'll review it and I'll let you know by email. It's a good question. I didn't memorize that by heart, but it's like the right hand rule, you know. I don't memorize stuff like that by heart, but I'll send you an email. Yeah, but I think you need to give an energy to a photon, to an electron to go in a lower orbit, and when it goes into a higher orbit, it's gonna lose energy. Yeah. So yeah.
Oh,
That's
so we have a question, Phil, if you don't mind answering it real quick.
sure.
A viewer of mine, Core, said, "Are photons what are emitted when a hologram is projected? If so, what happens to the photons that shatter outside of the spectrometer, as it were?" He said he's a novice and he's still learning.
Is that a question in the chat?
It's in my chat. Yeah, you won't see it on the StreamYard.
Okay. So can you repeat the question? Sorry.
Yeah, I'm gonna put it in our chat real quick.
Okay.
It's give me 1 second. Yeah, copy it.
My brain is a little slow
It's okay.
tonight.
Yeah, sometimes you have to read it. I know.
Yeah.
Yeah. Are photons what are emitted when a hologram is projected? If so, what happens to the protons that shatter outside of the spectrometer, as it were? I don't even understand the question myself. So you guys are this is above me.
Are photons what are emitted when it's kind of are photons? Does it means do photons what are emitted when a hologram is projected?
Yeah,
Yeah,
big
photon.
hologram, I would imagine.
Yeah, photons would have to be ejected. Now the protons, I'm not sure about.
Oh no, it's all photons. I'm sorry, I might have said proton on accident.
Oh, okay. So yeah, it's emitting photons. Yes.
A spectrometer is used to. A spectrometer is used to. You know when you have like when you measure.
Isn't it
You
used
want
to
to
measure a bunch of
detect
different elements?
Yeah, when you do, you want to identify the material that the planet is made of. Then you
Oh,
run a spectrometer, and it's gonna give you a vertical bars of different colors and stuff like that, and the different colors represents the material that
right.
constitutes the planet or the object you're looking at. So he's talking about holograms and spectrometers. So I don't know what's the link here.
Yeah, maybe spectrometer is the wrong tool that he's referring to. Maybe he's confusing that. I'm not sure.
Yeah, yeah. I need a
Well, wouldn't it be the
clear
wave?
question.
Wouldn't it be a photon wavelengths analyzer that would tell you what phase in the in the spectrum, from visible light to what's not visible? It would be a frequency, obviously, right? Because
Yeah,
Right.
photons work on frequency. So depending on the frequency, if it's a high resonant frequency photon, it's not in the visible spectrum. There's only a small little window gap that
Hmm.
we can only see within the physical spectrum. When you
Hmm.
go below it, only certain animals are able to detect it. When you go beyond that window that we can see in the higher frequency, that's non-visible light to us. We can't see it. So yeah, there is a chart. You could probably pull it up on Google, and it'll show you that spectrum of what visibles photons you can see, what you can't see, and what's infrared. You know, so it has to do with frequency of photons.
yeah, exactly. That's how you identify materials that compose something.
Interesting. Yeah, thanks, Core, for your question. We really appreciate questions from chat. Honestly, that question was above me. I needed to address the team for that one.
A question about Gerald there. Simple Man 911 is talking about Gerald.
Gerard Morin.
Yeah. Oh, sorry.
Yes,
Yes.
it is in a resident state.
Said, that makes sense, and thank you.
Oh yeah. The other thing I want to say before I leave is I randomly watched the Jeremy Reese podcast this week, and I saw Salvatore Pais. He wanted to start a debate. It's like, geez, I've been waiting 3 years for that in the Epic chat, and everybody ran away. So if people they don't know what the real debate is. I've been debating myself on CosmoQuest against hundreds of physicists for 10 years and international skeptics. So if they want to debate, why don't they come here? I give them 2 weeks to come to your show, and we'll do a real debate on your show.
Phil's ready to put back on his battle armor.
Yeah, and I'll be sleepy half of the time, so like usual.
It's okay. Well, just draw eyes on your eyelids. And you can pre-record something.
Oh,
Good idea, man. Good idea.
well, he's going to give him a rebuttal. It's going to be snoring.
Oh my god. I'll be there. I'll be the first in line to see that.
I would pay to see that.
Oh,
Oh man, that's too funny. All right, so yeah, man, go Eagles, man. It's like let's do this. Let's make it happen. So I'm gonna salute you guys, and I'll see you next week.
Yeah, thanks.
Phil, have a great night and have a safe trip.
Yeah, thanks, Phil.
Yep.
Have a good
Have
night.
a safe trip, and take pictures.
Yeah, well,
Yeah.
take it easy, bros.
All right, have a good one.
Yeah, we'll see you when you get back, brother.
All right.
He's always entertaining. I love him.
Phil's great.
I like he's dedicated, very dedicated to what he's doing. It's not like he won't sidetrack from that. Like persistent. So yeah.
He's very tenacious.
Yes. Sure. Yeah. So Nathan, did you want to kind of do a recap on what you've done this week?
I'm sorry, say that one more time.
You want to recap on what you've done this week?
Oh, yeah. Dude, I've had a very busy week. So let's just say all day today I was in translating the AI voice, quite a bit of material, and I have it in the membership area right now. Some of it's not there yet. Basically, a lot of stuff from Linderman. Also, for the project that I'm working on, there was a PDF there, so I had that translated into it. I can't read on air, so I simply put it in for the AI to do it for me. So, but I got to click around all day to get it done. Just the busy work, I guess. I did that.
Yeah.
I was in my CAD today fixing that up. I made my prints ready to go today. I went through and checked bearing sizes because you got to print out the little piece. You know what I mean? See the bearing fits. Make sure you don't have anything in there that is going to have to be sanded out. It's got to be snug. I did all that work today. You know what I mean? Shaft has to fit right. So printed out those two little parts, just in sections. Now I'm confident when I run the regular print, I'll be able to do it. We're going to have those 3 spheres rotating. That's awesome. I was checking out the magnet size today, making sure everything was perfect in the fit there. Make sure they're in the right direction. But Yeah, all that's done, man. I got PLA coming tomorrow. As soon as it comes, man, my 3D printers are going to be ripping for about 4 days. And then I'll be ready to go with my project to fire it up hopefully on the 5th day. If everything goes right, that is. But yeah, it's coming along. I bought all the rods, the bearings. Like I said, I got the magnets, I got the motors, I got the drivers. I got all the rest of the stuff. I just had to perfect that thing today, so I spent a lot of time in that today. We're gonna have to do some preliminary experiments. I need to run the motor through my Tesla coil and the rod, let it spin. I need to make sure that energy isn't flying back into the coil when I do it. I'll have to see what I need to isolate. And I came up with an interesting solution for that energy that likes to go through everything. And it's just using fuel hose. It's thick enough. It won't go through it all that fast. And I'll get more of the directed energy straight to that little ball where I want it. So, yeah, I did a video today on it and just let everybody kind of know what I'm looking at doing, what my goals were. So I set all those, and that's Project Gravity Well. And in the next day or so, I'll put out the PDF that I was sent on the actual project that they did. I don't have any results on it. I just have their basic, hey, this is what we want to do. Now, I did pull some information from somebody who was in one of the Facebook groups, and they said that there was some weird phenomena going on. So I'm going to post that in there as well. So, yeah, just kind of some busy work today. You know what I mean? Didn't get in the lab and fry anything, unfortunately. Yeah, I got a new camera as well. So I got that ZV-E10 thing, and I got to dial that in so that my camera comes in clear now. So next part I need to work on is the
autofocus.
Dude, focus drives me nuts. I hate it. I absolutely hate it when it goes zoom in and out, and it drives me absolutely batty. I miss the days when you could just put it on a tripod and shoot and be done with it.
Yeah.
I mean,
Yeah, the manual focus, the slider was the best.
Yeah.
So I got a whole day of working on that to figure that out, because every time I set it and I had the right settings in it and it looks real clean, I go to pick up the camera, turn it on again, and all the settings are wrong again. So I'm not saving something somewhere or something's going on. So I need to put on quick sets to that thing and be done with it.
Yeah, you'll figure it out. It's just gonna take it's a learning curve with everything, you know.
Yeah. So it was ironic. I was doing the Linderman thing today, and he was talking about the cold energy and how it works. And it was like he was reading out of my notebook or something on exactly what I was doing. And it was hilarious because
Awesome.
he's got this book. It's like 36, I think it is, chapters. And I've translated one so far. Or not, I shouldn't say translated. That's a bad word. I put it into AI voice. Okay, that's what I was doing. So, but it turned out really cool.
Yeah, no, that's important. Just transcribing it from text to speech is important, because some people don't like to sit there and read. They'll like to listen while they're doing other stuff. So
Yeah, like an audio book.
Yeah, it's going to reach a larger audience. You know, people who wouldn't rather have read it are going to now have access to it.
Yeah. Like when I get an answer from Chat GPT, I like to put on the voice and just let it say it all out instead of reading the damn thing, because sometimes the answers are pretty long, right?
Yeah, that's true.
You know, I can learn more in 5 minutes of turning on my Tesla coil than ChatGPT could tell me about the whole system and how it works.
Yeah.
I'm sorry, guys. That's I'm with Gerald on this one. That stuff goes right in the fireplace. Say goodbye to it. We'll never see it again. I absolutely hate that thing. So, but a bunch of people with too much free time.
Video. Yeah, I used to do animations, and I wasn't very good at it, and it took a long time. Like even back in the day when I was in high school, like you should see some of the rudimentary animations I used to do. They were funny as hell, but they were just I can't draw, so I'd rather just hire somebody to do animations for me. I can't sit there for like 10 hours and do it. I mean, I don't have the patience anymore.
Yeah,
You're too young.
Hey, Mike, I wanted to give a shout out to Jarvis. He's became a member of your channel.
Oh, right. Yes. Right on.
Nice. Thank you, Jarvis. Yeah, Jarvis
Yeah,
is
thank you, Jarvis.
and then Sean stopped by and he sent us some love, so we appreciate that, Sean, as well.
Beauty.
Right on, man. Fun times, guys. Fun times. I got to make me another Star Trek episode. So
yeah, it's been a while since you did an episode. Yeah.
Yeah, I haven't been able to pull material, man. I've been busy. So hopefully in the next couple of days it clears out. You know what I mean? Trying to get ahead a little bit. So I'll do it while I'm 3D printing. It'll be fun to pull all the episodes together. So.
Yep. Very cool. Yeah, I've been working on my stuff all week and just I'm trying to get this one element, and so I went to the store to try to get it, and they didn't actually have it. So now I got to wait until see if the sales rep for that store can actually get a hold of the element I'm looking for my power cell technology. So as soon as I get that in, then I'm going to start the next build. So
Nice. So you have to rebuild those things before you go in for your testing, or what?
Yeah, we want to build a better setup than what we have. We made a couple of breakthroughs, actually initiating the piezoelectric effect in the cell. So we were able to do that last week. Kind of did it by accident and put the meters up to it and found out I was getting a better result when the cell's actually under pressure. So now, as far as thermo is concerned, I don't think I'm going to have a problem. I have a feeling down the road I'm going to have to put a heat sensor into the cell itself and monitor any kind of heat. But I don't think it's going to happen with the chemical makeup that we have. I don't think the heat's going to be really an issue. So
is it driving the air out of it when you put it under pressure?
Yeah, like all the air is pretty much going to be out of the cell when it's compressed. And yeah, I have to make a jig for it, put all the plates in there, and then it's actually going to have bolts and screws on the top. It's actually going to compress the cell down and create that piezoelectric effect.
Nice.
So yeah, yeah, it's going to turn out really cool. But yeah, there's been some ups and downs, right? So as far as like chemistry and stuff, that's where chat's kind of helped me out in a lot of ways, where a lot of people would stay away from it. But if you say like to ChatGPT, make me a cell, it'll come up with all these ideas, but it won't actually have factual information to back up its choices, right? It'll only come with what's in its database. And that's the flaw with ChatGPT. It doesn't know if you put this element and this element together, when you put them together, you're going to get this reaction. It doesn't know that. If it does know it, that means somebody else has put that info into the ChatGPT database, right? Because it's open source. Therefore, those questions might have come up before by somebody else, right? But I'm trying to base it more on my ingenuity than what chat's given me. But for certain elements, I want to get a little detailed information on the chemical makeup of whatever it is and how it might react with another element. Because we were talking last week when I put the PVA glue with Rochelle salt. That was a crazy reaction. I had no freaking idea that was going to happen. So it went endothermic on me and lost 10 degrees in temperature from ambient. Went from like 23 degrees down to 14.4 in seconds. It just dropped. the second it compressed and pushed all the water that was out of the PVA, reaction stopped. But the other thing too is it also created power. 0.6 volts at about 30 milliamps, not a huge amount of power, but the fact that this endothermic reaction happened, it was creating power. And I was like, whoa, that's cool. So that's showing me that certain elements can actually create negative energy power.
That is really interesting. Like, most times the fear is that it's gonna, it's the heat that worries people, but if this goes the other way around, that's very.
Yes, yeah, instead of heating up where you think it would heat up, the PVA made the the Rochelle cell made the PVA collapse on itself. It compressed. As that happened, all the water that was in that PVA got ejected. And at the same time, the temperature also dropped 10 degrees. And you could feel it in your hand. You could actually hold it. Feel
Yeah.
like, holy man, this is cooled off.
Very interesting.
Yeah, temperature is one of the main killers of systems, and people don't realize it. As soon as that temperature goes awry, your whole system's screwed. They'll get
Right.
readings like crazy everywhere.
Yeah. And then as soon as you go into the negative, guess what? You got superconductivity. You're getting more, it's taking less power to get through a system. And that's another unique aspect of the power cell technology I'm working on. The internal resistance of my battery is crazy. It's absolutely crazy. It's almost non-existent. My internal resistance is like 0.01 ohms, like so tiny. So to figure out how many watts or how many amps are coming out of that battery, well, basically 0 ohms is, they say, is impossible. Well, my meter is showing 0. And when I put the probes on the anode and cathode, it beeps right away. So I know I got conductivity. There's continuity there. So let's say, for sake of argument, it's 0.1 ohm, right? Based on that, if your cell's putting out 1.6 volts, you're technically putting out 1.6 amps. And that's DC voltage, not AC. So yeah, it's pretty impressive. Like most batteries, I would say, are probably in the 2 to 10 ohm resistance. I'll have to check some other batteries, but getting like less than 1 ohm resistance, that's pretty interesting. Very interesting.
Gotcha. Huh. Crazy. So a lot of that cold energy is on low voltage, and it's very, very little heat, if any.
Right. Exactly. See, now when I start doing my actual tests on the battery cell is I don't use an amp meter anymore because I can't really trust it. I'll actually do a resistance test between the anode and cathode.
Nice.
The resistances and then use the Ohm's law equation to figure out the amps. So I had a cell last week. It peaked out at 132 amps.
Nice.
132 amps. So what?
That's crazy.
Mm-hmm. Very low voltage, but the current's there.
Yeah, that's the hard one to get, huh?
Mm-hmm. That's the holy grail. If you could get the current in the battery. So
yeah, we'll have to get back into that, man. I can't wait to start running experiments again. I'm used to doing it like every other day. You know what I mean? And you get out of the groove of doing it.
Yeah, but sometimes it's good to step back for a couple of days and kind of regroup and kind of sort out what you want to do next and how to go about doing it. So obviously, you're going to be doing the 3D printing probably for the next few days. So yeah, it's not time lost. You're putting a new device together. So take your time with it, even if it takes a couple of weeks to get it, put together.
No, I understand. You know, the main thing is I just want to see it rotate a little bit.
Yeah.
Yeah, I mean, that's kind of thing. Even if they're half shells, I just want to see that they're rotating fine. That's
If you
it.
get a pop a couple caps in the meantime.
Yeah.
Yeah, really. Yeah. Yeah, you can see on his back, he'll have like a table at the back. And you know what you do, Nathan, is get like, the 25 volt, 20 nanofarads. You get about 600 of them all lined up. And every day before you start doing your experiments, set one off. Every day. Kind of like the 12 days of Christmas, but use caps and blow them up.
Oh, wow. Yeah, there's some small experiments that I wanted to do in the meantime. I was, like I said, looking at that Linderman thing. There's a lot of stuff in there, man. Little tiny experiments. There's schematics, everything. He's got 36 chapters in there. Absolutely amazing stuff in there. Bunch of reverse engineering for some of the projects in there. So they're all, you know what I mean? A lot of Tesla things in there. Just some of the things I just wanted to do forever, and it's just going to complete them while it's printing.
Yeah. They still have some videos posted out there back in the Borderland Sciences days, back in their early 80s. They were doing all the wireless transmission, all the original Tesla experiments done to Tesla's specifications. So they didn't change anything. They followed specifically all the stuff that Tesla did step by step. And he says that's the biggest problem with people today. They will not build the Tesla experiments exactly the way Tesla built it at that time period.
Yeah, because they want to take shortcuts. Tesla did everything by hand. He didn't have the components we had,
And the number one thing, where do they go wrong? Is when people start using those freaking MOSFETs. Oh, I hate them. I hate them. I hate MOSFETs. I hate those things. They're only good for one thing: garbage can. Unless you're doing like sophisticated switching, you're not worried about potentials and back EMF spiking and stuff like that. They have their uses, but for Tesla stuff, throw them in the garbage. Only used to disrupt.
Yeah, they're not very good for high amounts of energy. Like if you're doing something basic like lighting and stuff, that's different. But
you'll fry.
Yeah. Yeah, pulse motor is more efficient. For if I was going to do that I would do a pulse motor system with the coil.
Yeah, but I've always used the high-speed relay switch. I don't use MOSFETs. I've used them all. I've tried MOSFETs, SSRs, whatever. The best results and the best performance I ever got was with the relay switch.
Yeah, like a read sensor or something like that, or a Hall effect sensor.
Well, you used a Hall effect for a trigger. Pretty much that's the only electronic component I use on it. Other than that, everything else on my pulse motors, it's all analog. It's all analog. Like
that makes sense though.
Well, I used to read switches in the beginning, like the big ones that are in the vacuum tube ones, ones that are made in Russia, the really good ones. And they said, "Oh yeah, these things can handle 500 volts." I smoked them.
These things from old country, they will work.
From the old country, they were supposed to hold up to 500 volts.
You smoked it.
But I smoked it. What's going on with this? What's going on with this shit? It's all shit.
Oh man.
Oh, I have a little graveyard. I have this bag of all destroyed reed switches, magnetic reed switches.
Oh boy.
We call it the RIP bag.
Yeah. You have a use for them?
Oh, they're smoked. They're fried.
Yeah. But after they're dead, you collect them for a reason, just to display like.
Oh, I could make a little shrine,
Yeah, like make a little sculpture or something.
Yeah. I probably got at least 50 of them sitting in the bag. But that was showing me, these things were rated at 500 volts capable, and I was welding them. I was welding them close. Like
Hmm.
they were just frying. I'm going, wow. And I wasn't even using a big coil back then either, right? I had that timing down so right that it was just, you could feel the heat coming off the glass. Those are like vacuum tubes, right? I could feel the heat. And actually, I think on one occasion, I actually breached the glass. It actually broke.
Hmm.
That's how much of a spark I had going on in there. And it was hot, extremely
Nice.
hot. Yeah.
That'd be cool to see.
Mm.
Love it when things blow up.
Yeah, well, yeah, frying them is easy, but actually breaching the glass, I've only done it once. Yeah. So I tried to negate that. I put a diode on either side of it and take that back EMF and dump it into a cap or whatever. It didn't matter. That flash was so hot, so hard, it just welded it. It just went to liquid shit.
Yeah, I was thinking about what Jarvis said this last week, and he was talking about the 50 hertz motor going into the spark gap, which then has a big impulse spike, and then you let the Tesla coil ring afterward. And it
Yeah.
makes a lot of sense. You know what I mean? Because you
Well,
drive
that's
a lot more power into it. The spark gap, hits it,
yep.
spikes it harder, and then
Right.
pushes it on. So, yeah, I'm
Well,
going
that's
to start working on that.
yeah, because that's where you're getting the inductive reactance. That's when the inductive reactance happens in the coils when it starts ringing. You're getting that reverberation of energy in there, right? And then to boot, I'm slamming it right into a transducer, two of them,
Yeah.
and that ups the potential again. That's why I'm getting like well, the best result I ever got on my motor was about 1500 over unity. Like I
Yeah,
was
I
getting
think I can make a massive energy push. You know what I mean? With
yeah,
doing it that way. Because
yeah,
as soon as you start messing with the coil and putting things down, it starts pushing back on the offset. So if they're not there and it's just a spark gap, you can't push back on it. So
mhm,
it's going to shut that down real quick. So I can make a huge spike coming out the other end.
yeah,
So yeah, that's something I have to investigate. It's going to be
yeah.
like
Because
required.
because like I said before on many shows, the second my relay switch releases and I get that spark, any current that was going through that circuit now has now been stopped. That's why the battery doesn't run out of power. When that spark happens, that's where the energy is coming in from the environment into that orifice of the spark. That's why you're getting such a massive gain in power where you think you would get less. Because technically speaking, if you put, say, 12-volt battery and you put 12 volts into a coil, okay, you will never get a full 12 volts into the coil. It'll always be less, right?
Okay.
So when you're using the spark gap, now you've created an open system. Now the energy is coming from the environment into that coil. So now you've got more excessive power inside that coil ringing, and again, a resonant frequency, the ringing effect that we were talking about. That's when your potentials go way, way higher. That's where the over unity happens. But it
Hmm.
has to do with the physical break, and that spark has to be present. It's a bluish green spark. That's a radiant spark. Then you know that the environmental energy that's around it is now entering the system. It's been cut off, so there's nothing going into the battery. The
Yeah.
battery is stopped. The current has stopped in the battery. So therefore, there's less strain on the battery. So if you're pulsing this 5, 6 times per revolution, you basically have created an open system that's continuously open, but the system thinks it's closed because it's closing, opening, closing so fast at
Hmm.
a high rate. So it's like you're fooling the physics.
Hmm.
It's not closed. It's actually continuously open, and it's like John said, it's creating a charge pump. And that's exactly what it is. It's a pump, right? So whenever I see everybody working on pulse motors online and they're using MOSFETs, I just turn it off. I can't watch it. It just bothers me now. It's just like they don't get it. There's a couple guys out there that make really, really nice motors, beautiful motors, like very well designed, nice circuitry, everything, fantastic. What kills me, they're using MOSFETs. Bye bye. I'm gone. I won't even bother to watch it because I know it's already off the path. You'll never get the effects. And that's, Tesla was working with the same thing. Back then, all he had was brass and wood. He didn't have transistors. He didn't have fancy diodes or germanium diodes. That stuff wasn't invented yet. It wasn't invented for another 20 years later, right? After 1900. That's when some of those electronic stuff started coming out in the 1900s. Pre-1900, there was none of that shit. Didn't exist. His capacitors or his condensers, he made himself.
Yeah.
Right? All the coils made by himself. So it wasn't when he walked over down to the mall to the local Radio Shack.
Dude, we don't have a Radio Shack now.
Yeah, I know. I miss Radio Shack. We used to have it here. We used to sell all the good stuff that you couldn't really get anywhere else now. It's like you have to order all online now.
I'd probably go broke on the Radio Shack now. If they had what I wanted, oh my God.
Yeah,
It'd be like
especially with how
daily.
many there are. There's probably like one. You can drive all the way to the other end of the country for your one Radio Shack.
Well, I have
The
a
last one closed down, actually.
Well, I told you about that surplus guy that I go to. The problem is, it takes an hour for me to get there, right? From
That's
my
in
house.
Canada?
It's in Canada. It's in Etobicoke, which is the outskirts of Toronto,
yeah.
right? And he has like the best selection of surplus. Like it's crazy what this guy has. Like
I'd love to go there, but I'm afraid if I go there, I might
Yeah.
not want to go back to America, Mike.
Well, if I lived near, I tell you right now, if I lived, say, within 10 minutes of this place, I'd probably be in there every day.
Yeah, it sounds like a fun place to just hang out and because it's so big. You said it's so big. It's got so many different.
Hold on, I'm gonna put the address for it.
Yeah, maybe we can get a street view of it.
Well, he does deliver. So it's A1 Electronics.
I wonder if I can order anything. Does he have a website? Maybe I can order stuff online.
Yeah, that's what I'm trying to get now.
Oh, awesome. Because
A1
maybe
Electronics.
he would probably have some germanium diodes. I guarantee you he might have something like that.
Oh yeah. Oh god, yeah. He has tons of that stuff.
I need something like that. A germanium diode is what I've been looking for.
There. This is the place I go to, so I'll put the web address there.
What does it say?
All right, here's the address. I'll post it in the live chat if you guys want to check it out. He does deliver, so yeah, this place is nuts. You walk in there and it's wall to wall surplus. You name it, he's freaking got it. Well, he's got like tube oscilloscopes back like probably from the 50s, like some real old surplus stuff.
Probably got some analog meters I can grab. I need.
Oh yeah, he's got tons. Yeah, but he's got quite the inventory. Yeah, audio, radio, all the hookups, all the clamps, wire connectors, wiring, magnets, pretty much everything you can imagine. He's got a pretty large inventory. But that's the guy I go to if I need to get some special stuff. Like you just walk in there and it's like this row after row of stuff on either side. Crap is all over the floor. TVs, radios, motors on the ground, and you got about like 1 foot to walk.
So what's that place called again, Mike?
A1 Electronic Parts. www.a1parts.ca. I got it in the live chat.
Nice.
Yeah, he's got a very large inventory. Magnet wire, if you need magnet wire, they got huge rolls of it, so you can ask them to make custom size rolls, stuff like that. So, yeah. So it takes with the traffic here in the city where I live now, it takes me an hour to get there. It's just ridiculous. That's like middle of the day.
Yeah, it's sometimes worth it though. There's a hardware shop I got that's about 45 minutes away with traffic just sucks all around it. But when you get there, you get what you need, you know? So it's not like these big, hardware stores that just suck sometimes when you need something, real small or specific.
Mm-hmm.
Yeah.
No, like those giant blue capacitors, the big ones. Yeah, he's got tons of that stuff. There are row after row of this stuff. Yeah, AC, DC, all sizes.
Yeah, I like some of those places, man. You go in there, you really don't need a certain item. You just need a certain look of an item. You know what I mean? Because it's for like a off project or something. Those are the ones I like. They have variety everywhere. So you can just pick whatever you want, manipulate it the way you want to fit your project. Those are the ones I like. You know what I mean? The stuff you used to do before you had a 3D printer. Those are the ones I like.
Yeah, I built my first 3D printer myself. Riprap back in the old Riprap days. That was about 20. Yeah, right when my daughter was born, 2012. I was building my first 3D printer, and you know what? It was the best printer I ever built too. Very first one I made. It was so accurate. It was great. I couldn't believe how well it worked. Yeah. I'm just gonna scoot out for a quick smoke here, and I'll be right back.
My 3D printer is not working at the moment. I have to figure out what's wrong with the bed sensor.
So it's the bed sensor itself, Ben?
Yeah, it says temperature halt or something. Bed sensor. I replaced the board. I know it's not the board. It's just, I don't know. Maybe I moved something.
Was it the problem before you went into it?
No. The problem was the encoder. It got stuck. So I just replaced the display board or whatever. Just plugged it in and it worked. But when I started printing something, it's registering negative 14 degrees Celsius on the bed. So I know that the sensor is off.
Okay. They just have a little tiny sensor that's taped to the bottom. You know that, right?
It looks like it's glued. So should I try to remove that, or because it's glued on there?
First thing I would check. There's a MOSFET in the big housing. Make sure it's all plugged in. So one of the fastest ways to mess something up is that thing's just not plugged in all the way.
Oh, you're talking about the control box, the power supply?
As soon as you open it, there's a MOSFET in there.
Yeah, I pulled everything out. I couldn't see anything that was disconnected, but look for a MOSFET, you said? Maybe.
Okay, so there's two things. On the motherboard itself, there'll be a wire that goes up to a MOSFET. Okay. And it's over by the power connecting cord. So when you look for the plug-in in the back, right next to it, there's a small little board with a little MOSFET on it. That's for your bed. And that's what you need to look at. Make sure that's hooked in. If it's not, nothing will work. It'll give you the sensor problem.
Yeah, I wasn't sure exactly what to look for in terms of if something got disconnected. So now I can take it apart and take a look at that. Yeah, and if that's fine, then it's probably something that needs to be replaced.
Well, yeah, but usually it's just a loose wire because you got a trigger wire that comes from your motherboard. You have the heat automatically going through it from your DC power. You know what I mean? That goes into it, or AC to DC, however you want to say it. As soon as it goes in there, it converts it in that MOSFET.
Yeah, I was going to say, I didn't move it much. I just took apart the control box.
Could have just been loose, Ben.
Yeah. I'll take a look at it tonight.
As soon as you take off the bottom of one of those things, man, it's like a can of worms. Like everything you touch is like lightly put in the little place where it goes.
Okay, it's very delicate. I got you.
Yeah, so you kind of have to just start checking it. And that motherboard, it's not that hard. You could tell as soon as you get the bigger wires in there, you'll notice them right away. That's for your heat. Hey, Mike's got a new member and he's not here. Taryn Earthling,
nice.
that's awesome, brother. We
Thank
got
you,
two
Taryn.
today, Jarvis
Yes.
and Taryn.
That's awesome. We appreciate all you guys' love and support. Mike's channel, like all of our channels, are fueled by you guys. We wouldn't really be able to do any of this without you guys. So we really appreciate you.
Right on, man. We're all rocking it today.
Yeah. Yeah, I had 17 people watching me yesterday for the Benefactor's Guide to Free Energy Devices.
Oh, there you go.
It was the most we've ever had. It was a big moment, actually. So I'm really proud of that.
Some of these PDF bins, you can go on that 11 Labs, and it gives you 10,000, I don't know if it's words or whatever, and it automatically do the work for you.
Yeah, 11 Labs. I think I used that once. I'll have to go back to it and revisit it.
Yeah, I got the $5 plan that gives me 30,000. I think it's words. You know what I mean?
Right.
But you're able to convert it. It's an easy thing. You put up the paper there, and it reads it for you. And all you do is switch between voices, between a quote and a regular. And man, it's time consuming, but it's way easier than reading for me anyway.
Well, I don't mind reading, but after like a couple of hours, my voice starts to get hoarse, and I do like to take a break. So that would be good for me too. Take a break and let the AI read a little bit.
Well, I'm just saying, for a quick 4-page thing, it's really easy. Boom, boom, boom. It puts it out for you real quick.
Yeah, for sure. No, that's definitely a convenience. And then I think Michelle's been trying to transcribe that paper too. He put out one of the videos already on some of it. We went over it yesterday. So on the AutoGen.
Mm-hmm.
So there's some good stuff there, but I don't know. I don't think he used 11 Labs. He used something. I have to talk to him about what he used because it was not that good of an AI voice, I don't think.
Yeah.
But I think 11 Labs does a good job with the natural voice, and also Speechify does a good job too. But Speechify is expensive.
Yeah, I like the free thing, but I had such a thing, man. It was 60 pages, and I got through about 30, and then my thing ran out for the month.
Well, that's still a lot. 30 pages.
Yeah. Well, you know what though? It's worth every bit of it. Like I sent it to you a while back. It's the letter from Linderman that was in there. It was talking about all kinds of cold energy stuff, negative energy, however you want to say it. All of it's in there. He's cut like a book, man. It's just unbelievable. So it's like a how-to guide on every single project you work on that's cold energy.
Well, that's cool. Oh, I think Mike's coming back.
Nice. Yeah. Yeah, read it. Nathan's right. That's right. Pretty interesting thing, man. That's why I put it on I did the AI time because I don't think people read it when you tell them, hey, go over and read this or do that. You know what I mean? So just throw it on when you're working in your lab. Man, you'll just be sitting there looking at this thing going, are you kidding me? That's what they were talking about the whole time? You know what I mean? Like it's really that simple that you just have to figure out this, this, and this, and you're done.
Yeah, people have a tendency to overcomplicate things, and these systems are really basic when you understand how they work.
Yeah. I like it, man. So if I'm soldering something, usually I just hang out, listen to some AC/DC, you know what I mean? Do some soldering, do some coil building.
Mm-hmm.
But I'll listen to this stuff all day. You know what I mean? Throw on some Linderman, you know what I mean? Throw on some old stuff, some like Tesla stuff that he did. You know what I mean? Whether it's a lecture or something, I'll listen to that stuff all day. So
Do you think Mike's video that he sent earlier about Tesla and the Eiffel Tower is like, do you think they really still use it till this day? Like, do they use it and people don't know?
I didn't catch that one. The Eiffel Tower video.
Yeah.
that video was awesome, by the way.
I must have missed that.
They were talking about doing experiments on the Eiffel Tower and doing like some Tesla Tower experiments kind of thing.
Mhm.
And there were strange lights going on and stuff like that. Hopefully Mike will play it here for us.
Oh, quick. Hide your paper airplane. Mike's back.
There's so I just want to answer this real quick, Lan. Coastal, I do have a PDF that I translated. It's in members, so I'll have it out in the next couple of days. But it gives you quite a bit of information on what he was looking to do with this machine we're working on.
Nice.
So hopefully that answers your question. But as I get more information, I'll keep putting it out on video.
Mhm.
Hey, Mike, you got that video you were showing earlier?
Which one?
The Paris Tower?
Oh,
Oh,
let's
Petty.
see. Hold on. Just bear with me for 1 second here.
Wow, something went off the rails in the chat.
Bear with me here for a second. I gotta check if I got it in my email. Oh yeah, hold on here. Where is it? Oh yeah, that's it there. Okay.
Yeah, Lulu, by the way, I hope it's real. That would be really cool.
I mean, it sounds like it's real, because if Tesla had any influence on the engineer, he would have probably like told him like, hey, this is how it's really gonna work. It could be as an artistic exhibit, but it has a double function.
Oh, yeah. Hey, they built a big tower. Why not use it for a little bit before, you know what I mean? They make it a museum or something.
Yeah.
Okay, I got the link for the video in the live chat there. Just click it's in Facebook.
Yeah, so I wanted to let everybody know
Yeah.
that because Simple Man said, "Give me over Unity." A few of us are on the verge, of OU, but Mike has already accomplished it. So, I mean, that's important to emphasize here. His batteries require no input power. That's phenomenal.
There it is. There's Gerald. What's up,
Hey,
Gerald?
Gerald, the Lord of the Rings.
The Eiffel Tower was originally an antenna for Edison. Nice. Yeah, that's what we're looking at.
Hear about that?
That's what
Wow.
Mike was showing off in the video. That's why I was hoping you'd play it.
Yeah, that's cool. I'd like to learn more.
That was a quick video, too. It was like a short.
Roll that beautiful Tesla footage.
You able to show that video, Mike, or is it something you can't?
I don't have my Facebook linked on my computer, only on my phone. Yeah, I don't have it linked up to my computer. It'll take me a few minutes to get logged into my Facebook. Yeah, I could try. Just have to bear with me here for a few minutes. Anyways, kind of the breakdown of what the video is. The Eiffel Tower was completed in 1889, and Tesla actually went to see Eiffel, and they got along great. They had a great conversation, and he was telling them about the Wardenclyffe Tower project that he was planning on building. So the conspiracy theory is that he was incorporating some of the designs that Tesla was doing into the Eiffel Tower. So when the Wardenclyffe Tower got powered up, he would be able to receive the power at the Eiffel Tower on the other side of the world in France.
Hmm.
And from France, from the Eiffel Tower, people could connect to it wirelessly and get their electricity that way. That was supposedly his idea to get the global wireless network going.
I mean, it makes a lot more sense than some giant art project.
Yeah.
Yeah, and at certain conditions, if you're there at the right time, the Eiffel Tower will attract a lot of electrostatic energy, and you'll actually see arcing and like coronas forming at the top of the tower, the Eiffel Tower.
That's natural?
Yep, natural static energies at that height, right? It's quite tall, so it's a connection point. So the Wardenclyffe Tower, when it was in complete resonance, it was in complete resonance with the atmosphere of the Earth. And all he had to do was send impulses of energy, and that would travel all the way through the ionosphere of the planet to the other side, and the Eiffel Tower would receive it. It would go into resonant frequency with Wardenclyffe.
That'd be really cool.
Yeah. Well, it would have proved that his system would be feasible to actually transmit power basically halfway across the planet.
Do you think they would tell us if it did work?
What's that?
If it had worked, do you think they would even tell us, or would it even be published?
Well, by 1903, J.P. Morgan basically cut all his funding, right?
Mm-hmm.
So, and it never got a chance to actually see if it would actually work. I think it would have if he actually got Wardenclyffe operational. I think he would have got connectivity with Paris. Yep, I do believe it.
They couldn't let that happen.
No, the banker guys, no, not at all. Yeah, there was another good video I saw today on YouTube. I was talking about the Astor family, the bankers, and he was dead set against the Fed, right? So all the Astor family and all those important guys at that time that were dead set against the Federal Reserve. What was happening? They got them all on the Titanic, and the conspiracy was that the Titanic was deliberately sunk to get rid of the Astor family.
Oh man!
And what was it? A month later, to the day after the Titanic sunk, they had the meeting at Jekyll Island, and that's when the Federal Reserve was put into operation. That's when the global bankers. Yep. So, yeah. And that was right off the coast of Newfoundland, right here in Canada.
A bunch of shady people, just like the that person over there in California wants to make a 30-minute city, 10-minute city.
Yeah, 15-minute cities. That's what they're doing here in Ontario. It's all 15-minute cities.
They want to do that now.
Oh, sorry.
Yeah, with the people's homes that are burnt down, they want to take them and make some junky city. And it's like, dude, that person should be fired immediately.
It just feels like they're replicating a matrix, so they don't worry about its configuration. So if it's similar, they know how to read it much easier because it's just replicas of each other versus the different mix of
that Titanic conspiracy is interesting. I have to look that up because that makes a lot of sense.
Because that's basically the way they're doing it here, how they're laying out the city structure here in Ontario, where I live. I could go 15 minutes in any direction and have all the anomalies that I could possibly want. I don't have to leave my city.
No, I understand that, and that's a fun concept. That's not what I was getting at. They're going to screw people out of their homes in order to do it.
Oh, yeah. Well,
I'm not okay with that at all.
Yeah. See, in Canada, uh, where we live is called Crown land. It's owned by the Crown. It's owned by the British Commonwealth, right? So if you want land, you can purchase the land, right? But you only have legal rights to that land for 100 years. Then it goes back to the Crown.
Yeah. What a waste.
Yep.
It's like a lease on a car.
It
You
is.
know, you know you're getting the smoker's car after that.
Nathan,
you're getting the
Those
raw
dirty
deal.
people. Yeah.
That's the way it is. Yep.
if you like decide to build a road, a toll road, you could only like benefit from it for 100 years, then becomes
Right.
property again. So it's
Yep. It becomes property of the Crown. That's the way the British Commonwealth. It's the same way in Australia. Any land that's considered Crown land by the British Commonwealth, that's what it is. You lease. You basically can only own the land for 100 years. Then it goes back to the Crown.
Yeah, no, thank
So,
you.
To ascribe to the Native Americans' philosophy is nobody owns the land.
Oh, yeah, try to tell them that now when you go into their casino. They will tell you they definitely own the land.
Oh, you're talking about the modern day Native Americans. But the classical philosophy is like, the idea of nobody should be owning the land, which
That's
is
just an
interesting.
idea. You can't go in there with your bearskin rug and your, you know what I mean, your little leather chonies. They'll throw you out on your butt.
Well, I'm just
they don't
speaking
like the
of
rain
the
dance.
philosophical aspect of having the earth, which is the lifespan of the earth is much longer than anybody's single lifespan. So the idea that one individual can own a part of the earth when its life is much longer and includes much more than just one single life entity is kind of a philosophical notion of, who really should own the land in general. That's the Native American philosophy, though.
yeah. Yeah.
Yeah, or they could just say there's a cataclysm later on in the century and you're screwed. That's
Well, I
generally
think
how it works.
what I think really happened in California, they deliberately burned all these homes down. And I heard BlackRock was in there buying up as much land as it could from people
Sure they
that just
were.
lost their homes, and they didn't have insurance on the homes to rebuild. So they say, okay, we'll give you pennies on the dollar. You dump your home, it becomes property of BlackRock. So and I know what they're going to put there is condominiums. It's all going to go up as condos.
like on the internet, like they had this things called the high energy beam. It's a weapon. Like they could beam it on anything and start a fire, or like they could use it from satellites, from offshore boats, from planes, from fighter jets, from like they could attach it to it, and they could pretty much protect it if this was what happened. So they've got the like and if they want an area, and nobody would ever find out. So like, if they started the fire for land, I mean, it's not a far-fetched idea.
Yeah.
Yeah.
Well, you know what? We tried to get rid of that governor once, and the morons voted him back in. That's their fault, And I'm not saying that in the way of hurting anyone for the fire or anything like that, but they voted for the incompetence, and they got the incompetence, and it just sucks that it has to work that way. So
It sucks that hardworking people lose what they built their whole lives just because of a government and wants to benefit somehow, and take people's hard-earned lifetime of gathering to pay off a house or a land, or not fair.
well, when they start running out all the insurance agencies, they should have all had red flags like going everywhere. You know what I mean? Like, why are they doing this? Why are they all leaving? Why am I left, you know what I mean, defenseless. They should have asked those questions and got rid of as many politicians as they had to get it fixed. And they didn't do that. You know what I mean? They kept on the same, oh, we're voting this because it's one side and la la la. You know what I mean? And it's just stupid. And
Yeah,
now
see, like,
we got this.
yeah, like in Canada, you cannot purchase a home without having home insurance. You have to by law.
Well, that's the way it is here. But once you already own the home and then they drop the fire insurance, which is not actually the insurance that they require for your home, it's on top of that. So, yeah. Well, they screwed everybody. Mandatory car insurance in California. Well, yeah, they bent everybody over. And then they don't regulate it, so now it's through the roof. I mean, it's ridiculous, man. You pay as much to the insurance company as you do for your car. I mean, it's just stupid. These politicians are morons, and people who vote for these morons are bigger morons. I mean, yeah, we got to just walking around looking at morons in California. That's what I do. You know what I mean? The stupid looking at the stupid is what we're doing. Night, Gerald. Yeah, anyway, whatever.
Yeah. Yeah, that's the way it goes. Everybody's getting robbed blind. That's the problem.
Yeah. Been getting robbed blind for a long time. Like we got the train to nowhere. Which is just a slush fund for California. That's really all it is. And if somebody looked into it, that's all they find.
Yeah, the same here. We got the stupid carbon tax, which is the biggest crock of crap.
Hey, who gets all that money? Like,
exactly, the government. It just goes into somebody's pockets in the government. What it is, yeah, it's such a crock of shit. It is. It's like blackmailing. Oh, you make pollution. Oh, you got to pay a tax. Okay, well, what's that tax money going to do? Well, I got an idea. How about fix the freaking roads? How about fix the sewer system that keeps failing year after year? Why don't they use it for something good? You know what I mean? But no, it probably goes into somebody's back pocket, right?
How about get rid of this lead in the water in Flint that's been there for 12 years?
Yeah, water purification systems. Get that all fixed up. You know, there's
pot. So you know you don't pop your tire like the tires. Right, you know.
Oh yeah.
Oh, that's bad. Yeah, the potholes are bad. They'll take out your tire. You're right.
Yeah, the city of Toronto's bad for potholes. Really bad.
Like here, I one time I got tired of there was one close to the house and there's no way around it. Like you know, I got a bag of concrete, bottles of water. I went there like in the street. I poured the water on top of it. And, you know, because nobody's doing it, and bag's like a couple of bucks, not a big deal, but at least they'll fill that hole. And so, yeah. So what? I'm going to call the city and make a complaint to file paperwork for them to send somebody that something costs like $10, $15 to, you know.
Yeah. Yeah.
Honestly.
It's like in Toronto, like fixing the roads. They're always fixing the 401. There's not one section of the 401 that they're not repairing at any given time, any time of the year. It's like they're spending millions upon tens of millions of dollars fixing the 401, but it never gets finished. It's like it's one continuous cash cow for these road and paving crews to fix the roads.
Yeah, they don't have it funded enough to finish the project. They just milk it.
Yeah, they're
so it's
are they ever milking it?
In general, Canadian concrete, it lasts a few years longer than the concrete we use here. So our concrete generally cracks within like 2 to 3 years. It'll start to crack.
Yeah, see, like we have
it's
stuff,
bad.
We use like an asphalt, so it's a mix of stone and rubber and tar. So because we get the winters here, you get flexing in the roads in the summertime. They expand in the summer, and then in the winter they contract. So
the hot asphalt helps with that, yeah.
Right, because it's rubberized. There's rubber, tar, and stone all mixed together, what we call asphalt. Right?
Yeah, we don't use a lot of that. We use mostly concrete, which, you get ice or you get water in it, it freezes into ice and cracks, and it doesn't last very long. And then, what they'll do is, instead of coming and patching the road, taking out the part of the road that's destroyed and replacing it, they'll just throw it a tar patch on there,
Right
a patch of asphalt,
Yep,
Or
right on top. Yeah.
metal, like a big old metal plate. They'll throw it on the road, and every time you go on, like a car goes on.
Or that, yeah.
Yeah.
I've
Yeah,
seen the
they-
metal
they-
plates
they-
where they were dangerous to go on, and they would like cut your tire, So
I've only seen that in downtown Toronto, but out where I live, they don't use the metal plates. It's always asphalt. It's always
yeah, and you like they set it down. If they set it down in a busy time, they set it down. We go away, and then the next car that drives by just takes it out.
Yeah. 401 is just something else. The 407, they used a lot of concrete to build it, but now you're starting to see, because the way our Canadian winters are, a lot of sections of the 407 are starting to get replaced, and they're replacing it with asphalt now because the concrete's just breaking away. It's just cracking up.
I believe the Gordie Howe Bridge is also pretty much finished, which means the money is going to be running out for those projects as well regarding the construction industry here. So, but that bridge is almost completely finished.
Yeah.
Doesn't the asphalt deteriorate much faster than the concrete?
Yeah, the asphalt does deteriorate, but it's put under a lot harder conditions, because of the Canadian winters. It puts a lot of stress on it. So
Yeah, and the way it deteriorates, it doesn't leave those potholes,
Yeah. Well,
as
you
much.
will. Well, we've even had some problems with getting sinkholes in Toronto.
That's a
Was
problem.
happening
Yeah,
in the U.S. Yeah, so we've had our fair share of sinkholes happening too.
those are
So,
scary. I'm from
yeah.
Florida, where I know all about you have to have sinkhole insurance for that state, for a lot of parts of that state. No, there was a guy just chilling in his bed, and all of a sudden a sinkhole just, and his brother came into his bedroom, and he was gone, just gone.
His
He
living room
was praying for holes and got the wrong kind.
Like the sinkholes are
The
fake.
final hole. The hole at the end of the tunnel. I
the
got
hole of all holes.
Holy moly.
Oh man! Good thing he wasn't in Canada. He would have got 3 holes.
Oh yeah.
Oh man.
Oh,
Oh man. Here we go off the rails.
Oh boy.
oh
Mega
man!
Mega hole.
Mega hole.
Swimming out.
New improved hole.
I got my hole on layaway.
Oh,
Oh god, my face is hurting already.
Okay,
Wow.
I'll take a break.
Whew. My mouth, my face is all like cramped up.
I know mine
Oh.
too. I'm laughing too much.
Oh man, it's so funny.
We
it
have fun.
hurts.
We have too much fun sometimes. If there is such a thing.
oh. That would suck. You're chilling in your bed and then you fall through a hole.
Yeah, it's terrifying when you think about it. All you can
It's
do
like-
is really laugh because it's just the prospect of it is so scary.
It's like, Dad, where are you?
How
I
much
don't know. He was sitting in his lazy boy. Now he's gone.
like that person's probably the unluckiest person on this entire planet for like the odds of somebody falling in a sinkhole are like almost slim to none, and for somebody
Yeah, that's like a Donnie Darko type statistic. It's, probably not going to happen to most people.
You get-
Well, unless you would
can't-
live in one of those places that rains too much where it's like tearing away the roadway, then there's definitely sinkholes everywhere.
Yeah.
You get the landslides.
Yeah.
Actually, they were saying
Those
something
are scary.
in California. They were scared because of the fires.
Yeah.
Like the ground, the roots are not holding the dirt anymore.
Yeah.
Oh,
So
yeah. Landslide. They had big mudslide.
yeah, it creates like just moving mud. Like
Yeah. Yeah. They were getting that in Alberta after, I think it was in Fort McMurray a couple of years ago. They had a really bad fire that took out the whole town. And they had quite a few of landslides and mudslides because, like you said, when the roots are all burned out, nothing's holding that ground anymore. And if you get a good rainstorm, guess what?
everything
You
moves.
got problems. Yeah,
Yeah.
the whole thing shifts, just like an avalanche of dirt.
It's scary.
Oh, man. Good times.
Mega hole. Mega hole.
Oh,
Hole.
that's so funny.
I'm just reading the chats here. The chat's going really good tonight, everybody. Live chat is open. If you're watching the show, you can join the live chat with everybody. And yeah, our live chats are always good. We're always getting good action on the live chat.
Well, you're getting good action because you presented the holes. That's the way
There
it
we
works. You start talking about holes, everybody gets involved.
It attracts everybody. We'll put that into the algorithm. We'll put it into our keywords for our site and everything. The 3 holes and see if our traffic goes up.
Dude, I could literally do a 2-hour stream just talking about holes, dude, making jokes about it. We'd never get anywhere, but it'd be hilarious.
Yeah.
I definitely watched that.
So
Yeah,
I have
right.
a singularity. Is the point of singularity there's no energy?
Point of singularity?
Yeah.
Oh no, they keep calling it a null zone. I don't get any energy from it.
So it's zero energy. So it would be like the 0 point energy would be the singularity.
Yeah, I don't know if we haven't reached the point where we've gotten to 0 point yet. You know what I mean?
No.
Like the null zone's there and we haven't opened it.
I think singularity goes a little further than that. I think it starts going into the consciousness realm. It starts, yeah, like singularity that I'm aware about is, everything is connected, right? All matter starts in the toroidal form. Basically like, EVOs and stuff like that, charge clusters, they're all the shape of toroids. Even thunderstorm generator at the molecular level, it's all going into toroids. Well, the center of the toroid is where 0 point is. They could be miniature little black holes. Here we go again, black holes. Hole again. It's all about the hole.
That's right.
I asked that question but to turn it the scientific one. So yeah, I mean it's just so the singularity, like it's not about consciousness, it's about like where it's the devoid of energy.
Well, the void is not void. It's simultaneously connected to everything.
Mm. Okay.
So time and space does not exist anymore. When you're in singularity, it doesn't matter if the other party's on the other side of the universe, you're still connected as one. That's singularity.
It almost feels like thing I read once called the Matryoshka mind, which is like the ultimate conscious mind that is connected to to everything.
Yeah. Everything in time and space. Time and space doesn't exist. Distance between you and the person that you're connected with is not. There is no distance. It's instantaneous. Say propagation. instantaneous communication. There is no lag. There's no latency between the connections. That's what they're saying. These toroids, even Nassim Harriman, he's talking about the singularity too, where basically all these plasmoidal, charged clusters, they actually have black holes, and they're tunneling between each other. That's why you could take a photon on one side of the universe and have the same split photon on the other side of the universe. You could turn one of them, and the other one on the other side of the universe will turn simultaneously at the same time, even though that they're not physically connected. And they've actually done this in the laboratory. So that's entanglement, right? So is entanglement part of what singularity is? So I'm connected to Nathan. I'm connected to you, Lulu. I'm connected to you, Ben.
Right.
Instantaneously.
Einstein called it spooky action at a distance.
Exactly. So I think it's part of entanglement. We're all connected, even though Nathan's in California, Ben's in Michigan, Lulu's in Texas, I'm in Toronto. We're all connected. So it's a very deep well, rabbit hole. That this singularity.
Holes.
Hole. Back to the hole.
You guys are all screwed now.
Mike was building up a moment, and then the momentum was just shattered.
Just pulled me through the hole.
I was gonna say, man, Mike, you make me feel less lonely, and then Nathan comes in with holes.
Well, John in the chat was saying it's like his balls hitting literally. I mean, what do you want me to tell you? Gone completely off the rails.
Yeah.
Oh man, we opened a can of worms tonight. I'm sorry about that.
I think the can of worms went down the hole.
Oh wow.
Oh,
we got John.
I'm sorry. I apologize.
No, we're all participants here. We're all guilty of the holes.
I still remember that video, man. That was the greatest. Ben was completely oblivious for the first few minutes. He was following directions Mike was giving him, and Gerald and I couldn't stop laughing.
It's still a classic.
It was the best video ever.
Oh my God.
Because we're sitting in the back, right? And we're just like, dude, should we say anything? And it just kept going. It was perfect.
No, there was a point, I think it was midway through, after you guys were already probably laughing.
Then caught on.
I realized what was going on.
The way Mike said it, though, was perfect, man. It was the straightest faced answer because he was really into what he was doing, and it was just, it was otherworldly, man.
It was one of those classic moments that will go down in history as one of the funniest.
Oh, it was the best. Good times.
You gotta create a montage of all the funniest moments.
Oh my God.
Yeah, the funniest things just come out of the blue and unexpected. They're classics.
Oh, it happens all day, though.
Happens all day.
I just sit around cracking myself up, man. It doesn't stop when the camera shut down. My family gets it too, man. So that, you know what I mean? You go in there and you tell a bunch of jokes and get on people, and then they turn around, and as soon as I walk in the door, man, they hit me with it. So it's a fun house, man.
Like John says, it's like disruptive discharge.
Oh,
That's good.
I get that after eating my burritos with my one wire energy. Get a lot of disruptive discharge.
Talk
My
about a
eyes are
real
watering.
static field.
Oh my god. Yeah. Yeah, more like the Richter scale.
Hey, have you ever been in a situation where you got to clear out of the room that you farted in? Then,
Yeah. Well, that's what I used to do at work, right? Yeah, it's true. Listen to this. This is the best thing ever. I see somebody and he's coming right at my machine. I'll just, I'll just let a big deuce go, right?
What crap
And
does
usually, oh yeah, just
especially if it's somebody you don't like.
oh yeah, if somebody I don't like, oh yeah, he's getting a deuce, man.
Frank's over there talking shit.
Don't
about
go in
my
there,
wife.
Mike shit his pants.
He's like, he walks by. He's like, "You smell something?" No.
I would say, yeah, I would say no. I didn't smell it. No, I would just say no. I don't smell anything. But now that you think of it, since you showed up, now I can smell something.
You know what the
Oh my god.
part is that you guys have that on command.
Yes, it's a gift. It's a gift. Yeah.
Hey, well, no, not for me. You have to pull my finger first. I'm sorry. You walked right into that.
Yeah.
Oh wow.
I used to do that to my daughter when she was young. Pull my finger. Yeah.
Oh man.
Or the
time out. So
or the next the other good one. I was going to my grandmother's house at the time, and I was in the elevator, and I'm coming up to my grandma's up to her level there, and I let a deuce go, right? And as I getting out, there was somebody else coming in. So, anyways, they walk into a smoked out freaking elevator. The elevator closes, right? And all I hear from inside the elevator, holy shit.
Oh my god.
Oh, I laughed so hard. It was great.
Oh. Oh, it's so bad, man.
You ever see those videos where the guys are just walking like on the street and they'll just lift their leg and let let them go?
Those are hilarious.
Actions. Oh, I love those.
Oh man.
Hilarious.
Yeah, you gotta watch those sometimes, man, just to laugh.
Yeah. Oh yeah, they're great.
Dude, they gotta have something in the future where it makes your farts green. That would be just the funniest thing in the world, dude. I'd be eating that stuff all day just to see people's reactions as you walk through and blast them.
how dare you, good sir?
It's like when you get out of the bathroom and you announce that you were in there so that they walk by and it's like clotheslining them with the smell as they come by. And they all have to say something because you mentioned it.
Yeah. Oh, man.
Give you some free energy right here.
Ran out of my butthole. Here. Yeah. It's like, get a match. Let's see something.
Oh boy, that's gonna be explosive.
Wow. Oh God. I've heard of people's septic tanks blowing up because of a spark.
Oh wow.
Oh yeah.
Oh yeah.
Technically, if there's that much methane, though, can't you refeed the methane back into a system to utilize it?
Yep, some people do that. Yep.
Yep.
Instead of putting natural gas in, they'll put the methane gas and actually use that for heating.
That's what I'm interested in: energy recycling.
Mm-hmm.
Well, they do that, don't they? They recycle the methane that comes out of it on a farm.
Mm-hmm. Yeah, they do that with landfills too. So I imagine that you could have the same system.
Yep. Yeah, they do it to like say a lot of rural areas where they don't have, sewage systems, and where they all have the septic tanks.
Mm,
So they could utilize, the methane gas for heating the house in the winter, right?
right.
That's so bad. The farmer's in there on the shitter saying, "I'm heating my house."
Mhm.
What are you doing, Pa? I'm heating the house. Go back to
And
bed.
he, yeah, yeah, it's more like, yeah, I'm heating the house with my yesterday's cabbage rolls I just had.
Oh no,
Oh, wow.
those are bad. Oh,
We don't need that much heat.
Yeah. Oh.
Mr. Lania said poo. I feel you, Mr. Lanius.
oh yeah.
Beans. There you go. Yeah.
Oh, dude, that's so
Pork
great.
and beans.
Yeah,
Oh man.
they really like me being out in the garage, man. They don't have to deal with that. They said,
Yeah.
we send Dad out to the garage. He can go laugh at his own farts. So
Yeah.
instead of busting out the living room.
It's like, Dad, why are the garage door windows fogging up? You can write your name on the windows in his. Oh man.
I'm
Oh,
going to show our audience the little toy that I bought, the circuit, the one that.
Oh yeah.
Okay, so look at that. It generates current just by holding the two ends.
Right.
Look how cool this thing is. No batteries, nothing. It's just human energy.
Do you got the link for that on the internet for that device, or
It's called sci-fi tube.
That is
sci-fi?
crazy.
Yeah, it's like 14.5. The company that makes it is called Toys or Toy Smith.
I wonder if they use some kind of oscillation circuit.
I don't know, but I'll break it down.
Yeah, that would be cool. I'd
Yeah,
like to see that.
yeah, because there's no battery in it, so it's pretty cool.
I mean, that's a lot of light and sound for no battery.
Exactly, that's what my point was when I showed it
Mhm.
before. So it's
Yeah.
it's a lot just for, I would think, I don't know, but
I don't think people who don't do these experiments realize some of them how much energy actually costs to power something like that. Like
Mhm.
I struggle to power anything other than lights sometimes with my
There it is.
device.
yeah, but just
No.
for human energy, like just our energy to power up a sound and
Yeah, the speaker and all that. Yeah, that requires a significant input. So that's impressive for sure.
Hmm.
What did you say it was called?
called
Sci-fi tube.
Sci-Fi tube. I don't know if you could see it
Sci-fi
here,
tube.
or this is the.
sci-fi too.
Yeah.
That's cool.
Yeah.
I got it at the Natural Science Museum, their gift shop.
That's awesome.
Yeah,
I'm have to find one of
and a
those.
few magnets, like a few round magnets. Pretty cool.
Nice.
Yeah. Energy stick. Yeah, there's a few of them.
But I'll take it apart and like take pictures of it just so.
Probably what it is there's two magnets and there's two coils, and the magnets roll around inside the coil as you're playing with it. And that generates power and it stores it in a capacitor. So as long as you're like moving it around and stuff like that, and those magnets are flipping around inside the coils, you're going to generate power, right? Because you're cutting the lines of force, right?
See,
I
there's
think it's based on
nothing
movement.
on this side. There's nothing, and but this side, you could see it from here. I don't know. There is like a little I don't know what those things are called. And there's a little electrode from this side that runs. You see that little thing runs to this
Yeah,
side.
the LED.
So there's no batteries. That's the
Mhm.
Yeah, it's probably just a capacitor inside it, and as you move it around, it's got maybe a little magnet and a coil, and it's generating small amounts of power and stores it in the capacitor.
Yeah. But yeah, I'll take it apart and just, so you guys could see what the circuitry is. I'll try to make a little video of it, and maybe, I don't know.
So putting your hand on either end of each terminal completes the circuit.
Yeah. Tried it with like 4 of my kids. We held hands, and it still worked. Yeah, it's pretty cool. And the more you apply pressure, like okay, but if I apply more pressure on it, it works better. Less pressure, more. I don't know how the pressure mechanism, like, it's increasing its energy.
Yeah.
Yeah.
I wonder if it's not moving magnets around, but maybe utilizing bioelectric energy somehow, or biothermal.
I have no idea, but it's a pretty cool, nifty thing,
Huh. Yeah, we definitely have to take that apart and figure out what's going on in there.
Like, it could just be like when you take a tomato and you put the probes in both sides, you get a reading in there of how much energy is actually in there.
Yeah.
And then your body's kind of the same way. So it probably works on that same little bit of energy, just like body heat stores. It'll put some, like milliamps in there and a little bit of voltage. You know what I mean? I think that's how it's working.
But
I don't think that there's a magnet in there at all.
But to produce that much, with sound and, like,
the autogen doesn't require a magnet. It's just a coil, and it's got a dielectric in between to insulate the pipe. So it's not one solid pipe, but, it produces a lot of current with just frequency input. So that's just the tiniest amount of, electrical signal input that you can put in there, and it's producing a lot of current. So I don't know. It's probably not operating the same principle, but it's possible.
Well, no, wait.
Yeah, Jarvis says you got Jedi energy.
Jedi energy.
Yeah.
Well, I mean, magnets are nature's over unity devices. So if I was to utilize anything for over unity, I would try, utilizing a magnet or electromagnet.
Well, think about it. If you took that thing and went down the hallway now in your socks and you had carpet, could you build up a static charge and send that thing to explode?
Maybe. I wouldn't want to try it, but like if you had a home invader and you had a quick situation, make a makeshift bomb.
You're not making a taser out of it. You're just shocking somebody.
Yeah, rub your socks and then throw it and it blows up.
You must have some raunchy feet if you can get that much energy out of your socks, bro.
No, I was just raised on Home Alone.
Oh man.
Oh.
Make it into an electric.
Penthouse booby trapped. You go in there.
You know it.
Yeah.
You enter the bathroom and confetti flies in your face.
Yeah. Ben's socks turn into an electorate.
Oh, wow.
Hey, you're making the hair on the cat go straight up in the air.
Oh, that's so great.
Oh, man. Well, we're at the top of the hour. 2 hours go by fast when you're laughing and talking about the holes.
Oh, man, I should open a restaurant, the Three Holes.
3 holes.
Well, yeah, I've
Nathan's
been open
holes.
a motel next to me at the Three Holes Inn.
3 holes. Pick your hole. 1, 2, or 3.
Just be completely ambiguous too. Don't provide any other context.
Oh. Oh my.
Yeah.
Wow.
Oh my. Oh.
Oh my.
Oh my.
That's so great.
Oh man. So I guess we'll call it quits for the night. Everybody, thanks a lot. Live chat was great tonight. Thanks everybody for tuning in, and also our new members as well. Thanks a lot for joining. And Nathan goes live 1 o'clock Eastern, 10 o'clock Pacific. And Ben, do you have any live streams going this weekend, or?
I might do another mini lab this weekend. I'm not sure if it's going to be on Saturday or Sunday because I do have to work. So
Right.
I am going to try to do another mini lab though. If I do it, it will be late at night probably or earlier in the morning. So keep that in mind.
Very cool. Everybody can log into your channel and check out your live streams. Even if you do miss it, they'll always be recorded. And just click on the live tab on the benefactor main page. That goes for Nathan as well. If you miss a show, don't worry. They're all logged under live. And you can always watch the show at your earliest convenience. So, Lulu, Nathan, Ben, thanks a lot. We'll see everybody next Friday.
Have a good night, guys. Thank you.
Good night.
Thanks a lot. Good night.